This week on the show, we are having an article about causing ZFS corruption for fun and profit, a NetBSD Assembly Programming tutorial, the IKEA Lack Rack for servers, a new OmniOS Community Edition LTS has been published. We have an lsblk style listing for FreeBSD, a Project Trident 19.10 update, and more in this week's episode of BSD Now. BSD Now, episode 319, Lack Rack Jack, recorded for the 9th of October 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And as you might expect, this is a new episode of BSD Now, and we should jump right into our headlines this week, which is causing ZFS corruption for fun and profit.
Right. This is a post by Brian Elric from Datto, which is one of the companies that offers a backup service based on ZFS. And they say, Datto backs up data, and a lot of it. As of the time of this writing, Datto has over 500 petabytes of data stored on ZFS. This count includes both backup appliances we have sent to customers, as well as cloud storage servers that we used for secondary or tertiary backups of those appliances. At this scale, drive swaps are a daily occurrence, and data corruption is inevitable. How we handle this corruption when it happens determines whether we truly lose data or successfully restore from secondary backups. In this post, we'll be showing you some of how Datto has intentionally caused corruption on our testing environments to ensure we're building software that can properly handle these scenarios. Big disclaimer, you should absolutely not attempt these instructions on any system containing any data that you would like to keep. I provide no guarantee that the commands within this post will not completely destroy your Z-pool and your life.
Yeah, better not.
So it has some background on what is ZFS, but we don't really need to do that for this audience, do we? No.
No, not anymore.
So they talk a little bit about what the corruption might actually look like. So it says ZFS has mechanisms, referred to as scrub or scrubbing, to detect and repair silent data corruption. ZFS also gracefully handles drive failures and drive swaps. In this case, by corruption, we mean permanent data loss, where all of ZFS's internal backup replicas of the data are lost or destroyed. In a real-life scenario, this would be triggered or would be a trigger to recover destroyed data off an offsite replica or a backup. In practice, these scenarios are rare, since ZFS is designed around preventing permanent corruption. But therein lies the problem. Since these corruption events are so rare, it's hard to write code to handle these scenarios, unless, of course, you can cause the corruption yourself. So, in ZFS, each VDEV is responsible for maintaining its integrity, meaning that we normally spread copies around so that losing any number of drives within the tolerance is allowed. Right? So if you have a RAID Z3, even if you lose 2 or 3 drives at once, it's okay as long as you can replace them before the 4th drive fails. Or, that's why mirrors in ZFS are allowed to be as arbitrarily deep as you need. I have a couple machines that are actually 4 deep mirrors. So that means every block is written to 4 different drives. So that system will just keep going for a long time, even if some of the drives fail. So looking at their setup, for this example, we'll be using a realistic example, a Z-pool with a single mirror VDEV with 2 backing physical disks. So they have a mirror of 2 hard drives. So the cause of this corruption, since this is a mirror setup, a naive solution to cause corruption would be to randomly DD the same sector on both of these 2 physical disks. This works, but it's equally likely to have just overwritten random unused space rather than to actually have hit some data. What we really want is to corrupt a specific snapshot, or even more specifically, a certain file in that snapshot, to simulate a more realistic minor corruption event. Luckily, we have a tool called ZDB, the ZFS debugger, which lets us view some low-level information about datasets and files. So after they created a dataset called corruptme and wrote some test data to it, and then took a snapshot of it, they can then use the ZDB -DDD, so that's 3 levels of verbosity on dataset, on that snapshot, and they can see some information about it.
There it is. Yeah.
And then when they dig into it a little bit more, turning the verbosity up to 5, you can actually see the byte ranges that are used on the disk. Or using those, the DVA or data virtual address, this is where on the disk the data actually lives. If you use those addresses and feed them into ZDB with the capital R flag, it can actually output what's there. And in this case, you can see it's the lorem ipsum stuff they wrote to that file. And you can specify how much you want to read and so on. So then they can use DD to skip to that specific sector and write different data to it. So looking at what they're doing, they're trying to read from the SDB1, which is a physical mirror, in 512-byte blocks and skipping ahead to a certain offset. So why doesn't it work? It turns out that it's a little bit different than that because the offsets used in ZFS are relative to the start of the ZFS data area, not the start of the partition. So when they adjust the offset to account for that 4 megabyte ZFS header at the beginning of the partition, then with raw DD, they can figure out what sector number it is and see the data that they're trying to read. So now they see their lorem ipsum, and so they can write from dev urandom over top of that data. So now when they run a scrub, they'll get a checksum error on those blocks. And it'll be on both of the drives in the mirror, and so the mirror will be like, sorry, I don't have any copies of that block that are good. And now you have permanent error on that file, and you can see in that snapshot, so when you run zpool status, you'll see permanent data error, and it says that snapshot, this file is broken. You'll have to restore it from a backup. So congratulations, you've successfully destroyed your data. So at the 500 petabyte scale, it's not a matter of if data corruption will happen, but when. Intentionally causing corruption is one of the strategies we use to ensure we're building software that can handle these rare but inevitable cases. To others out there using ZFS, I'm curious to hear if you solve this problem in a different way. We did quite a bit of experimentation with the zinject command before going with the more brute force method described here. So I'd be especially interested if you've had any luck simulating corruption using the zinject thing, which allow you to basically inject failures so you can simulate them.
Yep.
I think this jives quite well with a pull request I've seen being worked on at Datto to do a special kind of ZFS send to recover one corrupted file from a snapshot without having to resend the entire snapshot.
Oh, yeah, just that area. Yeah.
Yeah, so basically, if, say, this simulation were to happen to you, they might actually be able to correct it by sending only those missing blocks.
Oh, yes. I think I remember there's also a geom class now to simulate these drive errors in FreeBSD head somewhere. I think they did something.
You can do some stuff like that with GNOP and others, yeah.
Mm.
But anyway, it's a good explanation of how to actually go from the data you get out of ZDB to where the data actually lives on disk.
Yeah, the debugger shows you that. Mm-hmm. Among other things.
But also it's describing the difference between the DVAs and where it ends up on disk. It can get more complicated if you're not using a mirror. If you actually use RAID Z, the DVA is relative to the virtual disk that is all of the sectors columnized in RAID Z, so it can be a bit more complicated. But
okay.
I'm pretty sure that's why they used a mirror in their example.
That's easier to demonstrate.
Yeah, but it comes down to, as a backup company, at some point, it makes more sense to just have a second separate backup rather than adding more redundancy to the first backup. Right? Like if they are using mirrors everywhere currently for their backups, they could add a third disk to each of those mirror VDEVs, and that way, if 2 drives did get corrupted, the third drive would still be okay, and they'd be able to recover the sector, and they wouldn't have to go to their secondary backup. But at some point, that storage is more expensive. Or, in particular, in their case of it's an appliance on site with the customer that's also backing up to the remote site, the remote site might be cheaper to have more hardware at. There's at some point you can be limited to how much space you have on site for more hard drives.
Yeah.
If you've seen pictures of my basement, there's not much room for very many more hard drives.
Mm-hmm. And storage needs keep rising.
Yeah. And so at some point, it can make more sense to have a whole second copy on a separate machine rather than increasing the level of redundancy on a single machine.
Yeah. So
because,
don't trust
at
everything.
Some point you also have to deal with, what if the CPU burns out or something, or the motherboard fails on this machine. So our backup is now offline. Hopefully we have a second backup somewhere. Because when you need to restore stuff, you usually need to restore it yesterday, not when we get around to fixing the backup machine.
Quickly, yeah. Yeah, as the disk drive keep rising, don't just put everything in one pool, leave a backup separate in case things fail. All right, so next story that we have is a NetBSD Assembly Programming tutorial that we found. And it's a Spark 64 version is also being prepared, they write at the beginning of their tutorial, and will be added here when done. This blog post provides how to write a simple Hello World program in pure assembly on NetBSD/AMD64. And they will not use or link against libc, nor use GCC to compile it, because for the fun of it. It will be using GNU-AS or GAS, and therefore the AT&T syntax instead of Intel. So the first question right up front is, why assembly? Answer is, why not? Because it's fun to program in assembly directly. Contrary to a popular belief, assembly programs aren't always faster than what optimizing compilers produce. Nevertheless, it's good to be able to read assembly, especially when debugging C programs. Then they have a section on NetBSD syscalls here. In order for a program to do anything, it needs to communicate with the kernel. This is done by the syscall interface. NetBSD syscall numbers are specified in sys syscall.h. A lot of sys in there. Syscall numbers are defined by macros, and the comments describe the return value and parameters. For example, the very simple close syscall returns an integer and takes an integer argument. And it is defined.
You tell it which file descriptor to close, and it returns whether it did it or not.
Yeah. That's the explanation here. And syscalls take the arguments in the same way as functions do. And NetBSD AMD64 syscall arguments are passed in the registers in this order. So they have RDI, RSI, RDX, then register 10, register 8, and register 9. And
who came up with that order?
Maybe it's the architecture somehow. That is listed in a comment in the syscalls.c file. The syscall number is passed in RAX, register AX, I guess. It wouldn't find there what is defined. Yeah. Syscall return values are in EAX. So, for example, if you were to write out hello world, and we will write a program like this in a moment, you would use the write syscall to ask the kernel to write these bytes to the standard output. So you can see it. DOS services worked in a similar way to syscalls. So NetBSD ELF secret sauce, the ELF headers that NetBSD has, they have a special section identifying them as that. If you try to run an ELF that does not have this section, it will fail with exec format error. So you need that section so that the system can interpret what kind of format this is. The AF code
with the ELF type, every binary has got a little header that tells you what kind it is. On FreeBSD, this can be used as part of the image activator stuff, for example, so that if you have a binary that's for FreeBSD ARM rather than AMD64, it knows to actually run the binary through QEMU to be able to translate it so that you can run it on your computer for cross-compiling and stuff like that. Or, for example, when you're using the Linux compatibility layer on FreeBSD, it knows to apply the changes based on the fact that it sees the binary says Linux on it.
Mm-hmm. Yeah, so that identifies what this program does or where it's belonging to.
Well, it's the same reason, like when you run file on the file command against a FreeBSD executable, it can tell you what version of FreeBSD it was compiled for.
Oh, yeah. So you can...
That's also the type of information that's stored there.
Yeah. Then they create a small makefile for it to just compile it. And then they talk a bit about the int3 program. Intel engineers designed a 1-byte opcode 0xCC that invokes interrupt 3, the debug interrupt. We can use that to see if the makefile works and our file executes. And they have a little assembly section for that as well. Let's see. This file has a little .text section where the code resides, the magic ident section to tell the kernel that this is a NetBSD executable, the file program that Alan mentioned, and this _start symbol that marks where the executable code starts. That's kind of a important thing to know, right? There's no main function here. It needs to have that start section. Save that as proc.s and assemble that with the make to run the makefile. And then when you run it, then you get trace/bpt trap core dumped. Oops. Well, this means that the preprocessor or the processor actually successfully executed your program. And if you run in GDB, the GNU debugger, or any other debugger, I guess, and run it, you can see that it's starting that program and it's received that signal, SIG trap, and that causes the breakpoint to happen, or the core dump. Cool. And then they go into a little bit more into calling syscalls, the ones that are existing already in the system, and there are a number of them. So the simplest syscall you can call is the exit syscall. It will cause your program to exit with the exit code specified as an argument. And they add that as well. And so there's a couple more sections about that. And eventually you have a full-fledged Hello World program.
Yeah, and then I see it through actually printing the Hello World program out.
Oh, yeah. So it's a Quine, a program that prints its own source code, maybe?
No, it doesn't print its own source code. It just
do the Hello World.
Hello World.
Okay. Fine. Yeah, that's a good start into the world of syscalls and assembly programming in general on NetBSD. All right, time for the news roundup this week. We found an interesting thing where we usually don't look for IT-specific stuff, the IKEA Lack Rack for servers.
Yes, I've heard of this one quite a few times and actually know a few people that have them. Actually, my sysadmin has one in his living room at the moment. And I think Dan Len Gill had one up until he got a real rack. So it turns out that IKEA makes this table. You know, as most people know, IKEA has funny Swedish-sounding names for all of their stuff.
Yeah.
There's a very nice little side table for your couch called Dave. Or, you know, they have all kinds of weird things. But they have this little mini end table thing called Lack, which is, I guess it's a side table technically. But it just happens to have exactly the right dimensions to fit rack-mountable type gear in it, and then be able to screw the rack mount stuff into the legs and end up with rack-mounted gear.
That makes it interesting for the nerds of us.
Yes. And so in this one example here that we got linked, they have just an Ethernet switch stuck into their little table. But I know Andrew has rails installed correctly all the way through the rack and actually has whole servers mounted in it properly.
Yeah.
You know, you probably really want to be able to have something with rails that can screw into both or all four legs rather than only the front, because levering off the front. But yeah, you can fit quite a bit of stuff in it. Or, you know, here's one example. They have a Lack Rack that is so full of switches, it's actually not touching the ground anymore. Or someone's got, what's this? 1, 2, 3, 5 Lack Racks put together.
Yeah, stacking up.
So they have a Lack Rack on the floor, and then on top of it, another Lack Rack with all the gear in it, so that to avoid the problem of the gear hanging off, it's all resting on a bottom table while screwed into the top table for stability and stacked from heaviest to lightest so that nothing is getting bent.
Yeah. Oh, they have also a pricing chart for various countries. So this is not too expensive. I mean, a whole rack would be more expensive, but yeah, it has other properties that make it interesting. So
can these prices possibly be right? The table only costs $10.
Yeah, seems like in German it's $5.99 or in euro. It maybe it's.
That seems like a lot of table to get for $5 for €5.
Yeah, maybe they sell it cheap because they want to.
Well, it is a relatively simple end table. I'm just.
Yeah, not sure what the production.
I assumed they'd be a little more expensive than that. So, wow, there you go. Problem solved.
Yeah, very well. Yeah. So
here's an example where somebody's got their switch purposely mounted with the ears on the back of the legs so that the initial bend of the cables and so on, it doesn't stick out at the table, and it's protected by the overhang of the table.
That also is a good idea.
Yeah.
So yeah,
lots of different ideas here.
So on your next IKEA visit, have a look for those. Maybe it will fit in your data center somewhere.
Yes, and they even have this, when temporarily not in use, multiple Lack Racks can be stacked in a space-efficient manner. Unlike real rack servers.
Yeah, that's a bit more space-hungry. But yeah, the idea is definitely good to use or abuse the original table.
Yeah, that's quite amusing.
Yeah, so check out the website for more pictures, and maybe you have some other ideas for this kind of hardware. Very nice. Okay, but we also have OmniOS Community Edition R151030 LTS. So this has been published already in May of 2019, but we thought this we haven't mentioned it, I guess, so we kind of do this now. So the OmniOS community is, or the Community Edition Association, more like, is proud to announce the general availability of OmniOS R151030, and this is published according to a 6-month release cycle. Wait, then they also have one coming up soon, if that's the cycle, 6 months, and if this has been published in May. Okay, we'll look for future announcements. So that LTS version takes over from R151028, published in November 2018, and since it's an LTS release, it also takes over from R151022. This release will be supported for 3 years, and is the first LTS release published by the OmniOS CE Association since taking over the reins from OmniTI in 2017. The next LTS release is scheduled for May 2021. Here we go. And the old stable 15.10.26 release is now end of life. And they have a release schedule for further details. They mentioned that this is only a small selection of the new features and bug fixes in the new release. They are listed on their website, of course. So system features, they have support for the SMB 2.1 client protocol has been added. The console now has full frame buffer support with variable resolution, more colors and Unicode fonts. So this is also visible in the bootloader. The
SMB client is something we'd really like to have in FreeBSD.
Yeah, I guess people have wanted that for a while now.
The SMB1 client we had was fine up until recently when everybody disabled support for the old version.
Yeah, security and all. So they also have several 32-bit only packages that have been moved to 64-bit only. Yeah, go with the times. OmniOS userland is now built with GCC version 8. And the default installation now includes NTPsec in place of NTP. The package can still be removed if not required. And they have a couple of system default parameters set. They're now installed in /etc/system.d_omnios:system:defaults. And can be overwritten if necessary by creating additional local files under that etc system.d directory. They have also updates for commands and command options, zones. ZFS as well. Support for importing pools using a temporary name, and support for variable size D nodes. Okay, very nice. They have hardware support section supporting for modern AMD and Intel systems, new para virtualization drivers for running OmniOS under Microsoft Hyper-V and Azure in a beta version, and these are delivered by new driver Hyper-V PV packages, new BNX Broadcom Net Extreme network driver, and improved support for USB 3.1. All right, very nice. So we have now mentioned that, even though the release has happened in May already. Sorry about that. But yeah, here you know it now.
So next we have a post by Vermidon talking about listing block devices on FreeBSD in the style of the lsblk command from Linux. So he goes on, when I work on a Linux system, I usually miss many of the nice FreeBSD tools like sockstat, gstat, tops IO mode, tops ability to sort by columns from the command line, USB config, RC order, BE ADM and BECTL, the idle and real-time priority commands, and so on and so on. But sometimes, which rarely happens, is a Linux having a very useful tool that's not available on FreeBSD. An example of this is lsblk, which does one thing and does it well. It lists all the block devices and their contents. It has some problems like listing a disk that is entirely under a ZFS pool, on which lsblk displays two partitions instead of information about what ZFS is doing and so on. But if you look at slblk or lsblk on Linux, you'll see it says, oh, you have this disk, and it's this big, and it's of this type, and it's mounted over here. Mm-hmm. But it also has a tree. So if you have, for example, SDA, your main hard drive, and you can see it's about 1 terabyte, but it has a 500 megabyte boot partition and then its main partition, which in this case is actually LVM, which is their logical volume manager, and is split up into 3 different subpartitions, basically. Or you can see that you have SDC and SDD, 2 other hard drives that are partitioned, but then are put together with MD RAID to make a RAID 10 on the /data partition. So those 2 disks are basically mirrored like you would do with gmirror. So when you want that information, it can be a little harder to come by in FreeBSD, especially because some of the tools are subsystem specific. For example, FreeBSD offers the cam control utility, which if you do cam control dev list, will give you a list of all the disks that are attached, except for it's not always quite all of them. NVMe devices usually show up under NVMe control dev list rather than cam control dev list, depending on your mode. Certain RAID controllers don't display the disks properly, and you have to go get the list from somewhere else for those. And it's not the most parsable format ever from cam control dev list. And then you have the geom commands, like geom disk list, which is helpful and very verbose, but not really machine readable at all. Or gpart, which is what I often use. But if a disk isn't partitioned at all, it won't show up in the list because it has no partitions. Like if it doesn't have even a partition scheme laid down, like MBR or GPT, and meaning that the disk could not show up when it actually maybe needs to. And I have some example outputs of all 3 of those here. And I say, these provide the needed information in an acceptable manner, but only on systems with a small number of disks. If you would like to display a summary of all system drive contents, he has written this lsblk.sh, which allows some interesting features like -s SCSI or -s inverse modes. I focused on providing only the basic features to list the system block devices and their contents, as I have long and pleasing experience with writing shell scripts like BEADM and AutoMount. I thought that writing lsblk might be a good idea. And so when it started out, it was only 400 lines of code, and it was a pretty straightforward use of a combination of these tools that he's talked about. And he has some example output, which was somewhat useful. I'm not sure that the major and minor numbers are that useful, but I guess having the same format as the Linux tool means that scripts that try to parse the output might have a better time.
Yep.
And then he shows a more complicated example where he's actually showing the partition labels and whether they're mounted or not, or if they're used by ZFS. And then he added some more help and usage stuff. And then he rewrote 75% of the program.
Yeah, first versions and all.
And started bundling in information from glabel. and then dealing with Fuse file systems as well. And then, what if you have Gedley encrypted disks? And Fuse and all this other stuff. And so you end up now near the bottom where you have all kinds of data now. And to have examples of FreeBSD, NTFS, and FAT32 formatted disks, mixes of, mixing in Fuse and ZFS and other file systems and all of that to get as much information as possible printed on the screen here. The kind of thing like this that I've wanted sometimes was more about where the disk is in my system. So if you run, I think it's cam control dev list with -v, you get a very human readable only output that can tell you a bit more information, which then combined with some sysctl stuff from the hardware tree, you can figure out, this disk is on HCI channel 3, which is connected to this specific SATA controller, and basically eventually work backwards and figure out which SATA port a disk might actually be plugged into.
Yeah. Oh, yeah.
And yeah, I'd like to look at expanding a tool like that. Well, lsblk is useful, and I want to, you get disks and their partitions and so on. I actually want to go the opposite direction. It's like, here's my list of disks, but here's how they're actually connected to the system, going through the HCI channels that they're in and up to the controller that they're connected to. Or especially for JBOD type things, it's on this one of your LSI controllers and in this shelf, and get as much of that kind of information as possible. And try to output stuff in a machine usable format when I want to do stuff like, I want to make my new Z pool, and I want to use, for each VDEV, I want to use 2 disks from each different shelf. So that in my RAID Z2, if one shelf goes offline, that only takes out 2 disks from the same VDEV, and it doesn't fault the pool.
Yeah, you want that redundancy over the shelves.
Yeah, and stuff like that. But it can be awfully hard to figure out what disks are where. Like the sesutil map utility helps a bit, but it would just need to be a bunch of extra code to figure out what's where.
Yeah. Yeah, to make Let's Blink and which drive to pull.
There's that stuff too, but in this case, it's just figuring out which drives are where so that I can decide how to lay out my ZFS pool.
Mm. Oh, I see in the comment section that people are already asking for a port, and Vermiden is on that. He's working on it. And so we can maybe in the future find this in the ports collection. He has a GitHub project for that, of course. If people want to contribute code or send pull requests, that would be a nice thing.
At this point, he's basically rewrote it 5 times. So give him another couple days to finish rewriting it a 6th time, and then we'll get the port.
Well, that's dedication, certainly. All right, very nice. So thanks for that. And we have some updates from Project Trident 19.10. So this is now available. This is a general package update to the current release repository based upon TrueOS 19.10. They have some package changes. They have 601.
Yeah, so this is basically the automated snapshot. So if you look at the one we covered like last week, that was the stable 12 branch. This is the head 19 current branch.
The latest and greatest so far. So they have 601 new packages. They have 165 deleted packages and 3,341 updated packages. So chances are...
I think that's mostly because the default version of Ruby changed to 2.6.
Oh, yes, that covers a lot of other ports. You throw a stone there.
Lots of Ruby gems had to be updated.
Yeah. So that's a big refresh for packages. Yeah. This version of Project Trident. But definitely get it. So you have the 19.10 and can help test out a little bit or use it as your main driver, maybe. Very nice. So, time for the Beastie Bits this week. It's a NetBSD building tools. We found a picture about that. What's this showing? This is this a boot? No, wait. Why? This is booting on an Apple, or at least from an Apple connected keyboard. And what's it showing on the right? The right is a kind of a compile run.
Yeah, I'm not entirely sure.
Is there some cross-compiling maybe from an Apple?
I don't think so. I'm not sure why TG put this in the...
There's no description here. Okay, well, we'll leave it to the imagination.
I guess you're right. It must be on an Apple because it has a FaceTime camera.
Yeah, not many other devices have that. So I guess they can now cross-compile?
Well, it's not cross-compile. It's running NetBSD 9 natively on some Apple device.
Yeah. Okay. Well, because NetBSD runs pretty much everywhere and all the architectures you might imagine. Okay, well, good to know. There's no further description here, so we have to guess what more. The next one is a bit more descriptive because sponsorships have opened for SNMP Mastery. Yes, this is Michael W. Lucas writing yet another book. So he writes, my next tech book will be SNMP Mastery. Much like PAM Mastery, I'm writing this book as a public service. SNMP is an uncomfortable fact of life. It's baroque, obtuse, and misunderstood. Now that I've shipped the pseudo-mastery sponsor gifts, I'm opening print and ebook sponsorships, and there are links for both of those in his blog post. He's opened those for SNMP Mastery. The voices in his head tell him that he needs to write this with Lovecraftian cosmic horror reference. Yes, please. Because SNMP. Who knows if that'll actually work in the manuscript, however. So we'll stay tuned for that.
When asked a bit about it, apparently the Jails book is not selling very well. And I'm wondering why that is. Why doesn't everybody go out and buy a copy of the Jails book? Because no matter how much you think you know about Jails, there's something you don't know in that book. And it will make your life better.
It's definitely a good book to have. Even if you're not currently working with Jails much, it's good to have if you do. Because
just by knowing in the back of your head what you could do with Jails means that next time you're having a problem, it will dawn on you that, I see how I could solve this.
Yeah. Encapsulate all your system services or your projects or your services that you have in little Jails, and then you will be...
Yes, like I have a bunch going on here in the system. Like I needed a GitLab setup, so definitely that's in a Jail. It's 800 dependencies and so on. But it's like, I need to set up a VPN. I don't really want the VPN to take over my host system, or even in particular, I don't want this VPN to be able to access my home network, even though it's running on my home NAS. So I put that in a vImage Jail. So it has its own separate network stack, and it has different IP addresses, and it's in its own VLAN, and it works great, even from inside a Jail. Which, in the past, the VPN and stuff were one of the few things you couldn't do in a Jail, but now you can.
Yeah.
It's all there in the book. And so, yes, I have a bunch of different Jails. I have some Jails that don't have any networking, or some Jails that don't have any restrictions.
Yeah, you can fine-tune this Jail, what it can do or can't do, because...
yes, for example, you can make a Jail that is a CH root of / and doesn't have restrictions on what device entries it can access. And so then it just becomes a process group, kind of. It's just this kind of container thing, but it's not separate from your whole system.
Yeah. Or you can limit it to use only one CPU or just 500K of memory or cool things like that. So you can really mess with people if you just give them access to the Jail this way. But yeah, we digress. Definitely check out Michael W. Lucas's books. And if you have a little money left, then why don't you sponsor his SNMP Mastery book that's coming soon, or what is currently working on. Okay, then we have some news from Package Source because it's 2019, quarter 3. This release announcement is out for the new Package Source version, or the quarterly release, I would say. They are proud to announce the 64th quarterly release of Package Source, the cross-platform packaging system. Package Source is available with more than 20,000 packages running on 23 separate platforms. And you can find more information, of course, on packagesource.org. So in summary, 301 packages were added, many new games, emulators, audio tools. I guess I lost a lot of people after mentioning games. R and Ruby packages. 114 packages were removed and 1,682 package updates were made to 1,280 unique packages. Wow, that's a lot. Part of the TechLive packages were updated for the 2019 release as well. Okay.
And have new versions of Blender, Emacs, Firefox, Go, LibreOffice, Mate, Mesa, Mono, Mumble, MySQL, Nextcloud, PHP, Postgres, Python, Ruby, Rust, SQLite, VLC, WeChat, etc. And notable removals are getting rid of Postgres 8 and 9.1, 2, and 3, but you can still have Postgres 9.4, 9.5, 9.6, 10, and 11.
Yep, these are fairly recent still. So yeah, check out the new package source quarterly drop or release. Well, what's next here? No, it's not prefetch. It's PF. Is it
pfetch?
Pfetch, not fetch. pfetch something. Pfetch, a simple system information tool written in POSIX SH, which is why it's having the P in front. It's doing what you think. It's showing you a simple system information tool written entirely in POSIX shell using features built into the language itself where possible. And the source code is highly documented, and they hope here that it will act as a learning resource for POSIX SH and simple information detection across various different operating systems. If you remember a previous episode we did, there was the Pure SH Bible, which was well received.
The same person has now made a tool. What was that? I think it was NeoFetch was the one we looked at before that had all the colors and stuff, but was not very good at detecting BSD and kept saying like insane amounts of RAM and so on. Whereas this tool is written in pure POSIX SH, so it'll work on all the operating systems.
Oh yes, they have a OS support section. They support all the Linuxes under the sun. Android, the BSDs, in particular Dragonfly, FreeBSD, NetBSD, and OpenBSD. Windows as well, because now they have a subsystem for Linux as well. Haiku, macOS, Minix, and Solaris. So this tool should be fairly portable, which is why POSIX exists in the first place. You can see a bit of source code and configuration for it, so you can tune it a little bit to your liking. And yeah, this is a nice way of showing you maybe in a corner of your screen, or if you're in the market for a new laptop, maybe you want to go to a store and check out what kind of support it has. Maybe you run this and see what it detects.
They also link to a separate tool they have called UFetch that is just ASCII art logos for all the operating systems.
Yeah, there's a use for that as well.
Yeah.
Message of the days and stuff. I can see a use case. Cool. Yeah. So yeah, yet another pure shell implementation, and you can see that this is a fairly straightforward language. Yeah, and fairly portable if you run it in bin.sh, not in bin bash or some other shells that people take for granted nowadays. All right. We stay a little bit with NetBSD. We're taking NetBSD kernel bug roast to the next level. Kernel fuzzers from Quick 80 2019 overview.
Yeah, from Kamil Rutarowski. I love the art at the beginning of this. It's a rabbit with two spray cans labeled sanitizer chasing down some bugs.
Yeah. Oh, yes. Yeah.
So this is from one of the talks at EuroBSDCon in Lillehammer, Norway, a couple of weeks back, as presented by...
Kamil?
No. Maciej Grochowski?
Oh, yeah.
I'm butchering that Polish name.
Probably, but the presentation is well worth looking at.
Yep, and the video for that should be up in not too long, but you have the slides now if you want them.
And
basically talks about using the different sanitizers, like the undefined behavior sanitizer, the address sanitizer, the kernel memory leak finder, the memory sanitizer, I forget what TSAN does. I forget.
Insert crickets here.
But
find
they
it
also
out.
talk about syscolor, Triforce ACL, other tools, and so on.
Mm-hmm. Yeah, so this is a good overview of what is out there and how you can use that to.
Lots of fuzzing work going on.
But we also saved the best for last, in my opinion, because people have been attempting or have been successful at cracking Ken Thompson's password.
Yeah, so here's a post from Lee New Kerwichin. So somewhere back around 2014, I found some dumps of the BSD 3 source code that happened to include the etc password file before passwords were stored in the master.password file or shadow file on Linux. So it had everybody's crypted passwords, including old-timers like Dennis Ritchie, Ken Thompson, Brian Kernighan, Steve Bourne, and Bill Joy. Since back then, they used the DES-based crypt algorithm, the hashes were relatively weak, since you were limited to 8 characters of input. If your password was more than 8 characters, it only looked at the first 8 characters, meaning you get any characters after the first 8 wrong, and it would still log you in. Mm-hmm. So they thought it would be easy to just crack those passwords using popular tools like John or Hashcat. Quickly, I cracked a fair deal of these passwords. Many of them were very weak, just lowercase words or whatever. Although Brian Kernighan's password was /.comma/.comma, which is easy to type on a QWERTY keyboard, and is special characters, so maybe not something most brute forcers or guessers would have gotten, but that's interesting. However, Ken's password eluded my cracking endeavors. Even an exhaustive search over all lowercase letter and digit combinations, which took several days back in 2014, yielded no results. Since the algorithm was developed by Ken Thompson and Robert Morris, I wondered what's up there. I also realized that compared to other password hashing schemes like NTLM, crypt turns out to be quite a bit slower to crack and perhaps also less optimized. So did he really use uppercase letters or even special characters? Back then, an exhaustive 7-bit password brute force search would have taken over 2 years on a modern machine. But recently, the topic came up at the Unix Heritage Society's mailing list, and this person shared their results and frustration in not being able to crack Ken's password. Finally, Nigel Williams came up with the answer. So they show the hash, which was, it's like 10 characters of uppercaseness or whatever. Crypt was pretty basic. It turns out that Ken's password was P/Q2-Q4 ! It took about 4 and a bit days on an AMD Radeon Vega 64 running Hashcat at about 930 million hashes per second during that time. Those familiar know that the hash rate fluctuates and slows down toward the end as you get the more silly passwords and so on. As it turns out, this is a chess move in the chess descriptive notation and the beginning of many common openings in chess. This fits very well with Ken Thompson's background in computer chess. So I'm very happy that this mystery has been solved now, and I'm pleased to finally have the answer.
See, this is interesting. I mean, you shouldn't crack people's passwords, but I guess from this perspective...
Well, yeah, BSD 3 would be from the 80s?
Yeah, from way back when. Yeah,
I think it'd be late 80s. I don't remember exactly.
Hope they switched to different
before I knew what a computer was.
Yeah, and I guess those are probably now in everyone's password checker, just in case people get...
Yes. The real tip is don't use only DES for passwords because, you can exhaust that space in a couple of days now.
Yeah.
What would have taken 2 years before doesn't anymore. And, the person who spent 4 days on it only used 1 video card by the sounds of it versus, a determined attacker could, go on Amazon and rent 100 video cards for a couple of days.
Yeah,
That
sure.
definitely wasn't a thing you could do back then.
No, not
You could
with
write a
that.
virus to take over lots of people's computers, but you couldn't just go and rent for a few $1,000s as many computers as you happen to need.
Yeah, so it's interesting not just to reveal the password, but also passwords, but also what the passwords reveal about the people using those. So yeah, we thought this would be interesting for people to see.
Yeah, it came up on IRC, and I was just like, "Ooh, I'm grabbing that story."
Time for feedback and questions this week. People have been sending us questions, but we could always use more. So if you have any question about the show, anything that you want us to mention, or that you have found a nice article about Unix that we missed, send this to feedback@bsdnow.tv, and it's probably then ending, or has a good chance of ending up in a future episode. The first one that we have here is Evil Ham with a couple questions. So Evil Ham writes, hello, Alan and Benedict, an interesting capitalization, and everyone else who makes this happen, this show. Yeah, all the people behind the scenes. You asked for feedback and questions, so feedback and questions you shall have. Okay, thank you for your show first. I specifically enjoy how you both sound like super understanding, well-meaning people. Keep that up. Yeah, we kind of fool people this way, right? Sometimes.
I'm not a nice person.
There's that, yeah. No. It's definitely appreciated. Thank you for that feedback. So further it goes. About 15 years ago, I was talked into trying Linux, and it became my main OS for some time, and it never stopped using it on servers. Okay, so about 2 years ago, I was using Windows as my day-to-day operating system, work stuff, but found myself doing more and more work on a Linux VM to control servers and stuff. It was then that I met a wonderful BSD mensch. So it's been nearly 2 years of being pestered with how BSDs are awesome, PF is awesome, ZFS is awesome. FreeBSD integrates super nicely with ZFS. Jails and base ports are a wonderful thing. At the beginning of this year, I had to set up a new NAS for work and had this BSD mensch around, so I used them to bootstrap me into using FreeBSD in 2 days. Excellent. That's kind of a nice boot camp of sorts. Fast forward 8 months, and I run the Windowsy things on IPv6 only VMs on Beehive. Have helped create 2 ports I was missing, the Elm format and language Elm. It's okay, great. With the wonderful help of Arrow D and BSD mensch, I write this from my FreeBSD 13 current laptop that is building Firefox and Poudriere. And when I SSH into my Linux servers, I suffer from Control-T syndrome. Yep. Or not being there. And when you need it, yeah, probably SIG-info and Zug syndrome. Yeah, exactly, in German. Yeah. I also successfully set up an OpenBSD router using just the base system. Well, very cool. So he has a longish introduction into all the specific parts. Where are the questions?
So question number 1.
That NAS was started, everything required encryption at rest on the whole OS, but it required remote decryption of the system. Threat being someone breaking in and stealing the device, not someone physically fiddling with things and patiently waiting. Having the Linux mentality, it was a bit mind-boggling to realize that there is no equivalent to initramfs where to run like a drop-bear instance, for example, to remotely unlock the disk and move on with the boot. Instead, we figured out that we should install a base system on an unencrypted Z-pool, unlock, and then run the kernel mount root from, set the mount root prompt basically, and reboot -R into the fully encrypted system. Kind of elegant and straightforward. Actually, a beauty of the base port separation.
Yeah, I'd like to make that a little easier for people too.
Unfortunately, setting this up was not as straightforward as we had liked, since the installer can throw you into a shell and let you do it yourself. BSD installed ZFS boot is pretty much an all-or-nothing script.
Yes, that is a downside of it. I kind of realized that when I had to write up the wiki instructions as I did it on my laptop of, oh, I bought this laptop, it has Windows on it. I might need that every once in a while. So I'm going to shrink that Windows partition and have this free space, and I'd like to install FreeBSD into it. And the installer's only option is overwrite the whole hard drive with FreeBSD.
Yeah, there's that. Okay, sure. What I would have liked would have been something like ZFS boot setup pool script step that takes a disk or a Galley encrypted partition and uses the nice defaults on it and does only that. I'm a bit unsure if extracting this step would be interesting at all for the project, and not really sure how to go about that implicit question.
Yeah, there might be some value in splitting ZFS boot into 2 or 3 separate parts, like laying down the partitions and such, and then the one that actually sets up the pool. So 3 parts: partitioning the disks, setting up the pool, and then creating the file systems. Because sometimes you'd like to be able to say, hey, here's a list of disks and this layout, please make the pool for me. Or I already have a pool now that I've created manually with my fancy setup. Now please put a normal FreeBSD install on top of it. And then optionally maybe have that be extended to have an option of make me this unencrypted pre-boot environment that will just reroute me into the newer system. The other current problem with the reroute concept is that the kernel, you don't reload the kernel when you reroute. And so you have to make sure to keep the kernel that's in that pre-boot environment in sync with the kernel that you would normally be trying to run. And so it can hinder things with boot environments a little bit.
Oh, yes, yeah. That's that needs to be considered.
Something we maybe could figure out how to get around.
So he's a bit unsure if extracting this step would be interesting at all for the project. Yeah, that we mentioned. He knows that it's mostly a matter of changing stuff in user bin BSD installed scripts, but don't really think that's worth the full developer's handbook effort at the moment. Well, reading that is always nice for other things. So also a bit unsure if this kind of setup is something perfectly obvious to BSD people or considered utterly useless, and that's why the internet appears to not know about it. Well, there are use cases.
A couple of other people who do it, they usually just use something like MFS BSD for ease of use. But it's definitely useful and something I know a number of people do, and making it easier would be good.
Yeah. So don't hold back. Send us a review, a patch. Why not?
I know that there's been some talk about, BSD install 2.0. So definitely. I have some ideas written down somewhere. I built like a flowchart of what I thought the user-facing steps to an install should be. Trying to basically, I think right now BSD install asks too many questions. And, gets to the point that it confuses the user to get them to give up instead of getting to the end of the install. And there's a lot that could be done to improve things. And so we're definitely open to ideas and discussions on that.
Okay, so the second question is, I've been defaulting to SNDIO and compiling my media ports with it. It seems to work much better for me, and I really wonder 2 things that the internet doesn't appear to know. Are there plans to having it be the default on FreeBSD? Is that even doable?
I don't even know. I thought SNDIO was an OpenBSD thing. I didn't know that was a thing on FreeBSD. I have no idea what the defaults might be. That might be best to... It's not really in the purview of the graphics working group, but they tend to be the people that know what's happening with desktop-y stuff. It might be something to ask Nicholas or the other people in the FreeBSD-X11 channel on EFNet.
Yeah, that's a good start to ask. And we don't have much more on this question. The third question is, PF is indeed awesome, but on FreeBSD it's missing wonderful things like NAT64, and the syntax is by now not fully compatible with that in OpenBSD. Is there a story behind that? Well, other than one person working on it.
PF was ported from OpenBSD to FreeBSD, and then lots and lots of FreeBSD specific work was done on it to improve performance and add features like the VNet support, so you can have multiple instances of PF so that each jail could have its own PF if you wanted, and things like that. And that means that its source code doesn't really resemble what's in OpenBSD anymore, and it's not as easy as just, here's 4 new commits from OpenBSD that we can just pull in and apply to FreeBSD, and it'll just work.
Help is definitely
could be fixed, but it would cost money, and nobody has been offering up money for it. All the work on things like NAT64 were done in IPFW because it's higher performance and happens to be what the people that spend money on firewalls tend to use. Yeah.
So definitely, thanks to the current maintainer Christoph, he's doing a lot of work, and but it's definitely too difficult for a single person to catch up with all the upstream changes.
Well, in their spare time anyway.
Yeah, it's not a full-time job here.
Yes. It could be done, but nobody has offered to pay for it.
Yeah. So that's the current situation. And if you want to help out and work into that a little bit, definitely that's a thing you can do. And it seems like you're on a good start. Definitely say thanks to your BSD mensch and all the people who brought you into this world of Unix. And yeah, thanks for your questions. And thanks also for the 2 ports that you now maintain. That's a good start after a couple months into the project. Very nice. The next is Rob with an APU2 alternatives and GPT partition types question. Sounds complicated, but it's short in the question itself. Alan and Benedict, Rob writes, thanks for your wonderful program, dudes. Sure. First question, do you know of any tier 1 computer with good NICs that's similar to the APU2, but uses newer components like DDR4 memory? Is the APU2 still a good buy?
I've not really investigated those type of computers much. I know that AMD has some new systems that they happen to also call APUs, which are low end of the new, they're not, I don't think they're really Ryzen, but they're based on Zen or something. I don't know. There's some low end AMD systems that are very modern and low power and have things like DDR4 that maybe be able to fit what you're looking for. Maybe the rest of the viewers know more because I do not have any suggestions because the lowest end thing that I use in production is like an E3.
Yeah, I also don't have much about that. So we definitely should give that out to the listeners. Maybe they have similar, better setups or have bought one recently, so they know if it's still good or not. The second question is probably closer to what we can answer. What GPT partition type settings should I use with Galley when my GPT partition is consumed by Galley Guillaume instead of being consumed by a file system directly? I feel like FreeBSD, FreeBSD-UFS, and FreeBSD-ZFS are all lies.
Kind of, but it turns out the bootloader stuff, the bootstrap stuff, uses that to tell what file system to try to read. So if it's ZFS inside the Galley, you probably want it to say FreeBSD-ZFS, so the bootloader actually tries to interpret it as ZFS. I looked at adding a FreeBSD-Galley type, but then the bootloader would have no way of knowing what's supposed to be inside of that.
Because it's encrypted.
Yeah. Well, no, because if you set the type to geom, it's not going to know what type it is. Whereas if you set the type to ZFS, it's like, oh, if I decrypt this, it will be ZFS.
Yes. Yeah.
So, yes, I understand the question and the niggling that it provides. But you probably don't want to solve that problem right now because it will cause a much bigger problem.
Yeah. Just grind your teeth and be done with it. So for now, unless you want to grind your teeth into that problem. But as Alan said, it's a bit more involved than just changing a label. Okay, but thanks for those questions. And last but not least, to this week is Tom with the FreeBSD. Yes, a question about the journal article that Andrew Fengler recently wrote for the FreeBSD journal. Thanks for that at this point to Andrew. So Tom writes, hey, Alan and Benedict, I'm here with another question on jails. I was reading the article Advanced Jail Management with EasyJail in the now free FreeBSD journal. And yeah, definitely check out the free journals. It's free now. People haven't noticed that. Yes, you can read all the journals now for free without paying money. So back to the question. He mentions, since the router is not, and this is quoted, since the router is not doing NAT, any jail with a private IP address will not be able to connect out. We can work around this by running our own NAT somewhere, but we probably do not want to NAT our entire server. We can change the FIB or routing table for the jail, unquote. So, however, he does not explain how you should actually perform the NAT between the two routing tables or the FIBs. The FreeBSD handbook also does not mention multiple routing tables, so I'm left to wonder how.
Right. So in general, the idea with multiple FIBs or routing tables is that the second or third routing table you have uses a different default gateway. So on the host system that's going directly out to the internet, it will use the default route of your ISP, which in this case goes directly out to the internet and doesn't do any NAT. And so for all the public IPs on the host, this works best because we don't go through another machine. But the jails, as using internal IP, needs to use some other machine as its default gateway that will do the NAT. So in this particular case, we have, say, a bunch of different virtual machines at a provider, say like DigitalOcean. So if you have 5 different machines at DigitalOcean, on each of those machines, you're going to want the host, the VM itself, to be using the DigitalOcean router that is provided. But if you run a bunch of internal jails on top of those, you can set up just one of those machines to do NAT and have all of the different machines go over the internal network that DigitalOcean provides and get NATed out via that one. So basically, it's just having the jails have a different default gateway than the host. So the article specifically doesn't cover setting up NAT because it's generally meant to be, it's just some other router on the network rather than something you're meant to set up yourself.
Yeah. But it's definitely a good question about because this is not an uncommon or too uncommon type of setup for jails.
Right. So the misconception Tom seems to have is about, he keeps mentioning doing that between the 2 routing tables, and it's not. Each jail is either in that routing table or in the other routing table. And so basically the jail has a routing table that just has a different default gateway than the host. And then whatever default gateway you're pointing to is meant to do the NAT. If you just want to do the NAT on the host on the way out, then you don't need to do something like this at all. But in our scale engine setup, we had like 20 plus machines, and it didn't make sense to set up NAT on all 20 machines versus have all 20 machines go use a specific machine we had to do their NAT out of one IP address, while the rest of the host machines still talk directly to the ISP's router, so that the gigabits of traffic we're sending to the internet aren't having to go through our poor little NAT machine. So that machine doesn't become a single point of failure, where all of our internet-facing traffic is really running off the redundant router of the ISP, so that there's no extra machines for us to manage or extra bottlenecks there. And then just the jails that need NAT because they don't have real IP addresses are going out via our little NAT machine.
Yeah, that should help answering that question or clean up the article a little bit. So yeah, thanks for that question. And that pretty much wraps up our episode for this week. Thank you for listening. And again, if you have any show topics or content for us, then send an email to feedback@bsdnow.tv.